Hello, dear students. Welcome to Ark Institute. I am Dr. R.K. Saini, and today we are going to take very important mock test for the NEET examination. As you know, chemistry in NEET consists of 45 questions divided into three parts, namely inorganic, organic, and physical chemistry. But today we are focusing only on inorganic chemistry, and I have selected the most important 15 questions for you. If you solve these questions seriously, I can assure you that your concept will become much stronger and your confidence will increase. So stay focused, give your best, and let's begin to these tests. Question first, taken from chemical bonding and related to hybridization state. For example, in BF3, in list first, some compounds are given, and in list second, orbitals which take part in hybridization. For example, in BF3, the hybridization state of boron is sp2. Hybridization state of boron is sp2, and we know that in sp2, namely three orbitals, namely one s orbital, know its name because it is non-directional, and two p orbitals, namely px and py, involved in hybridization and make three hybrid orbital, and hence in BF3, three orbitals, namely s, px, and py. In case of HCF4, the hybridization state of xenon is sp3d2. Because 4 bond pair and 2 lone pair are there. And in sp3d2, s orbital, all three px orbital, namely px, py, and pz, and 2 d orbitals, namely dx square minus y square and dz square. Because the geometry of hybrid orbitals is octahedral, in which 4 bonds are lying in the plane and 2 bonds are above and below to the plane, and as d orbital, namely dx square minus y square and dz square, involved in such hybridization state. Therefore, in HCF4, the hybridization state is this. In PF5, the hybridization state is sp3d. In sp3d, two geometries are there. First, trigonal bipyramidal is most common, and it has trigonal bipyramidal is geometry in which d orbital is dz square, namely one s orbital, all three px, py, pz, and namely dz square involved in this hybridization state. Therefore, PF5 similar to the PCl5. And in case of BeCl2 has sp hybridization, it means one s and one p, namely pz orbital, because the pz orbital in general, z axis taken as a molecular axis. Therefore, pz orbital involved, and as make two hybrid orbitals, and they are arranged 180 degree to each other. Therefore, question first related to hybridization state, and select the other. Question number next. Question second is taken from D and F block element. You know that in inorganic chemistry, namely periodic table, chemical bonding, coordination chemistry, D and F block are very, very important topic. Question second, chromium, vanadium, and manganese, enthalpy of atomization. We know that enthalpy of atomization mainly depends upon the attraction forces between metal atom, or we can say metallic bond. And the metallic bond in case of vanadium is stronger, and its atomization enthalpy greater than chromium also, and as the atomization enthalpy of vanadium is highest, then chromium, and then manganese. Therefore, first option is incorrect. In case of density, we know that when we down the group, the density increases in D block element or generally in periodic table, because mass more increase than size, and as this order is also incorrect. Melting point, manganese, nickel, and scandium. Manganese, due to half-filled electronic configuration, its bond formation tendency is very weak. Therefore, the melting point atomization enthalpy of manganese is less. Therefore, highest melting point of nickel, second scandium, and manganese position at third in case of melting point. Therefore, this option is also correct. Also incorrect. And in last, electrode potential. We know that when we move from left to right in periodic table or in D block series, the electrode potential increase. because their cation formation tendency decrease due to high ionization enthalpy, etc. Therefore, the electrode potential value is increased. However, the electrode potential of copper is also greater than zinc, or we can say highest in 3D series, because their second ionization enthalpy is highest, and hence option 4th is correct. These are the it is the important question and taken from D block element. Question next. This question also taken from chemical bonding and find percentage of S character at the centralum of xenon difluoride. First we find hybridization state in case of xenon difluoride. So in xenon difluoride, the hybridization state is sp3d, because 2 bond pair and 3 lone pairs, and hence hybridization state is sp3d. And we know that in 5 hybridorbital, s orbital is 1. Among 5 orbital, s orbital is 1. From 1 is 1 by 5, and for percentage we find from 100, and as 20% s character are there. Which pair of species does not exist in nature? This is common question and taken from chemical bonding as well as valency, periodic table, etc. First, He2, both pair of the species does not. NF3 exists, but He2 does not exist because the bond order will 0. And we know that if bond order of the species is 0, it means such a species does not exist in nature. In second option, ClF3 exists, but NCl5 does not, because nitrogen is second period element. It does not possess d orbital, empty d orbital, and cannot be expand their octet, and hence second one species not exist. In third, both species are exist in nature. First is potassium superoxide, and second one is SF6. It also exists because the sulfur is third period element and is consists 6 electron in their outermost shell, and hence it can be expanded their octet with more electronegative element like as fluorine and oxygen. Therefore, both species in option third are exist in nature. In case of fourth, PF5 does not exist because hydrogen, the electronegativity of hydrogen is not so much more, by which d orbital of PCl of phosphorus become contracted, and hence they make effective overlapping, and hence this species does not exist. And similarly in ClBr3, the central atom is Cl. It possesses empty d orbital, but bromine is less electronegative than chlorine. Therefore, their d orbital cannot be contracted, by which they make effective bond, and as both species are not exist in nature. D orbital, if central atom possesses d orbital, then it can be make bond, but before bonding these orbital become less diffuse, and the less diffuse phenomena takes place when such central atom combined with high electronegative element and smaller non-metals like as fluorine oxygen. Fluorine and oxygen are both for this purpose, and as fourth option, in which both species are not exist in nature. In question number 5th, very important, dipole moment of chlorobenzene is less than methyl chloride. This question is very important and is also present in the organic chemistry in their first chapter of 12th book, NCERT 12th book, alkyl halide and aryl halide. Question: dipole moment of chlorobenzene is less than methyl chloride. It is correct statement, because dipole moment depend upon the polarity, and polarity depends upon the electronegative difference. In chlorobenzene, the carbon is sp2. In methyl chloride, carbon is sp3. It means the carbon of chlorobenzene is more electronegative. Therefore, less difference in the polarity between carbon and chlorine, and hence dipole moment of chlorobenzene is less than the dipole moment of methyl chloride. The sentence is correct. Statement is correct. The dipole moment of chlorobenzene is less than methyl. And the statement second, due to more electronegativity of carbon in chlorobenzene. It is very correct explanation. More electronegativity of carbon in chlorobenzene. Carbon chlorine bond is less polar, and hence option first is correct. Statement first correct, second correct, and second is correct explanation of statement first. Therefore, answer first. Question number next. Question 6. Question 6 taken from coordination compound. In this complex, the oxidation state and coordination number of iron. Oxidation state of the iron because oxalate ion carry -2 charge and overall complex carry -1. Therefore, the oxidation state is +3. And the coordination number of iron is 6 because oxalate is bidentate ligand. Therefore, 4 bonds formed by the 2 oxalate and 2 bonds formed by the aqua or water ligand. And hence, +3 oxidation state and 6 is coordination number. Question 7 is very important, also taken from coordination chemistry. The compound, their IUPAC name, DD splitting, and nature of complex. And first we find we write IUPAC name of this compound. The oxidation state of manganese is +3 because potassium carry +1, chlorine carry -1, and water is a neutral. Therefore, Mn carry +4 oxidation, +3 oxidation state, and as its correct name. And the anionic complex carry negative charge. Anionic complex carry negative charge. Therefore, we use ATE as a suffix in the name of metal ion. मतलब means magnate. Potassium tetrafluorido diaqua, first diaqua because alphabetically aqua comes first from fluorido. Potassium diaqua tetrafluorido magnate third. Its IUPAC name. And in manganese +3, the 4 electron present in d orbital and the complex is octahedral. Therefore, following arrangement of d orbital in octahedral field T2G and EG. Now the ligands are weak field ligand and hence 1 by 1 electron means delta O is less than pairing energy. Therefore, electronic configuration T2G3 and EG. And hence it is the high spin. High spin means number of unpaired electron in free state of metal ion in complex as well as free state are equal. Then it is known as high spin. And hence their IUPAC name and nature high spin and 4 unpaired electrons are there. Question 8. This question taken from MOT in chemical bonding. How many unpaired electron? Question, read carefully. How many unpaired electron are present in BMO, bonding molecular orbital? Both clearly. Bonding molecular orbital in O2. Answer 0 because all electrons in bonding BMO are paired. And however, it consists 2 unpaired electrons, namely anti-bonding 2px and anti-bonding pi 2py, 1 electron. Species is paramagnetic, but unpaired electron are not present in BMO, but they present in ABMO. And hence answer 0. Question number 8. Very important. And hence I suggest you, before writing the answer in their OMR sheet, question first you read question clearly, carefully, and then fill your OMR sheet. Question number 9. This question taken from periodic table, simple question. Ionization energy 1, 2, 3, 4, 5. किसी एलिमेंट की ionization enthalpy given 7.2, 14 point something. The element is likely to be. The value of ionization enthalpy are increases successively when electron removed, but the much more difference between 4th and 5th. It means much difference between 4th and 5th ionization enthalpy. It means after removal of 4 electron, the species become most stable, or we can say 4 electron present in their outermost shell. Therefore, the species likely to be silicon because it consists 4 electron in their outermost shell. Question next is also taken from periodic table. Some IUPAC notation on nil octium and IUPAC symbol, etc. First, such type questions are also asked in 2020. In this exam, a student secured perfect score in NEET, 720 among 720. And this question is also related. Such type questions also related in this question, in this paper. For example, nil octium. Octium. It means atomic number 118. Octium. And it is the inert gas and its IUPAC symbol is oxidation. Next, unbium. Unbium. It means atomic number 112 and it is the 6D element, last element of 6D series, and it is Copernician. CN. Copernician. CN 112. Next, transition element of 3D series has highest second ionization enthalpy. Transition element of 3D series, highest ionization enthalpy, and the answer is copper. And the atom has highest spin magnetic moment. The spin magnetic moment depends upon the number of unpaired electrons. Total 6 unpaired electrons present in chromium. Therefore, the atom of chromium has highest spin magnetic moment. Question number 10. Question number 11. This question is also taken from periodic table. First, increase atomic size. Increase atomic size may be first or may be second, but increase metallic character, metallic nature. The metallic nature increase in first option because neon is not a metal, and hence increasing metallic nature, B option related to first. Increasing atomic size related to B option. Increase electronegativity related to C, and increase electron affinity. Nitrogen has least electron affinity, or we can say its electron gain enthalpy will be taken with positive sign. It means it has no affinity toward the electron. Nitrogen, no affinity toward the electron. Therefore, its electron affinity is also less than boron, also less than carbon. Therefore, increasing electron affinity, option D. Increase electronegativity, option C, and this. Question next. Correct order of the decreasing nitrogen oxygen bond length. Nitrogen oxygen bond length depends upon the bond order. In case of NO2 positive, bond order is 2. NO2 positive, bond order 2. In case of NO2 minus, it has two resonating structure. Therefore, bond order is 1.5. Yep, here bond order is 2, complete double bond. In case nitrate ion, in case of nitrate ion, the bond order is 1.33 because fourth bond divide into 3 parts during the resonance, and as nitrogen oxygen bond length highest in nitrate ion, then small in nitrite, and least or very small in case of nitronium NO2 positive, and hence option 4 is correct. Question 13. Which set of the isomer dichlorobenzene having equal dipole moment of chlorobenzene and benzene? First, in case of chlorobenzene, one polar bond is there. If two chlorine present at their meta position, then their resultant dipole moment, because the bond angle is 120, and as we know that dipole moment is vector sum. Therefore, the dipole moment of two bond angle between these are 120 is equal to the one bond of same atom. Therefore, the dipole moment of chlorobenzene equals to meta dichlorobenzene. First, dichloro and benzene. Benzene is dipole moment of benzene is 0. Therefore, when two chlorine present in para position, therefore their dipole moment is also 0 because the bond angle of polar bond between 180, and we know that cos 180 equals to -1, and hence dipole moment of benzene equals to para dichlorobenzene and chlorobenzene equals to meta dichlorobenzene. Question next. Coordination compound are example of isomerism. This question taken from isomerism in case of coordination or complexes, and these complexes consist ambidentate ligand, and the ambidentate ligand show linkage isomerism, and hence in 14 question the answer is linkage isomerism. Question number 15 taken from Werner theory of coordination compound. 0.01 m. This compound was passed through the cation exchanger. Resin acid is formed. Acid means maybe 1 mole of HCl, maybe 2 mole of HCl, or maybe 3 mole of HCl. Maximum 3 mole of HCl can be formed. When this acid liberated was titrated with standard solution of KOH, the required 200 ml of 0.1 m KOH, the correct formula. First, we find moles of acid. We know that gram equivalent of acid become equals to the gram equivalent of base. The gram equivalent of base are given 0.1 m, X factor 1, volume 200 divided by 1000. It means 0.02 gram equivalent. X factor is 1. It means 0.02 moles are there. And hence 2 moles of chloride ion furnished by the complex. It means 2 chlorines are present outside the coordination sphere according to Werner theory. And hence option second is correct. Okay. And it is the paper of Inorganic Chemistry. Thank you.